Hi, my name is Chang and I'm from the University of Virginia. When we're doing the grocery, we're pretty good at judging the ripeness of the fruit, only with our bare hands. Indeed, we employ distinct exploration procedures to improve our perception. For instance, with respect to compliance, we exert pressure against a resisting force. Nearly all prior studies are employed man-made stimuli to stand in for naturalistic compliances. However, this assumption of equivalence has not been fully tested. Human perception is eventually tied with natural objects as opposed to these man-made fabricated stimuli. So therefore, in this work, we aim to quantify the touch interactions that can drive our perception for naturalistic compliances. In particular, we're using soft fruit. Tactile cues are quantified by biomechanics measurements, and the touch interactions are carried out using different exploration procedures like single finger touch and thumb index pinch grasp. Psychophysical evaluations are conducted to differentiate the soft versus hard plums. Indeed, to find out the contact areas are overlapped to be non-distinct between soft and hard plums. In aggregation with different subjects and different exploration procedures, we find out that gross contact area cues are indeed non-differentiable. Besides these, we define a new metric of virtual stiffness. The first observation of virtual stiffness is at the peak point of the force versus displacement curve. The second one is the fitted slope of the curve ramp. The final estimate is derived by the common fusion of these two observations. In discriminating with single fingers, people are actually matching their displacement to be the same and generating discriminable force cues. These kind of exploration strategies can actually be quantified by virtual stiffness cue, where higher stiffness is applied to harder plums. When moving to the two-finger case, higher force and lower displacement are applied to harder plums. However, these two cues are non-discriminable across different force levels. In contrast, the virtual stiffness cue can still reliably quantify the plum compliances, and it affords discrimination independent of the touch force. So in general, we develop new techniques for working with naturalistic compliant objects. The new metric of virtual stiffness cue can optimally quantify the exploration strategies. The results are inconsistent with prior studies, and it indicates that man-made stimuli are reasonable approximations to naturalistic compliances. Thank you.